many 3-digit numbers are divisible by 7? So first you should know what are the 3-digit numbers. So 3-digit numbers, the lowest 3-digit numbers, you know that. Lowest 3-digit number, which is the what is the lowest 3-digit number? It is 100. 100. Then 101. So like that 102. And then the highest, the greatest 3-digit number, you know that it is 999. Among this group of numbers, so you have to find out how many 3-digit numbers are divisible by 7. How many numbers are divisible by 7? So numbers divisible by 7. We need to find out numbers divisible by 7. So here, so we want to list out this one. How to find out the numbers divisible by 7? First you divide this 100 by 7. So divide this one. 7 ones are 7. So 3, 30, 7, 5, 7 fours are 28. 2 remains. So now if you subtract 2 from 100, so what happens? 100 minus 2. So it is 98. So 98 is divisible by 7. So add 7 to this one. So 98, because it is a 2-digit number, so we don't want that 2-digit number. So here, when you divide this 100 by 7, so you will get the remainder 2. Subtract this 2 from 100, so what happens? The 98 you will get. 98 is the number which is divisible by 7. Okay, but it is a 2-digit number. Add 7 to this one. Again add 7 to this one. It becomes 105. So this is the smallest 3-digit number that is divisible by 7. So numbers which are divisible by first number is 105. So 105. Then add 7 to this one. 105 plus 7. So what is the next number? 112. 112. Next number is 112. So next number, add 7 to this one. So 119. So the last number is 999. Again you do the same thing. Whether 999 is divisible by 7 or not. You divide this 999 by 7. 7 ones are 7, 2, 29, 7 fours are 28, 1 remains 19. 7 twos are 14. What is the remainder? Remainder is 5. Now subtract 5 from this 999. 999 minus 5. So it gives you 994. So this is the number which is divisible by the greatest number, 994, that is divisible by 7. So you can calculate by dividing 999 by 7, you will get the remainder 5. Subtract this 5 from this 999, then you will get the number which is divisible by 7. So 994 is the number which is divisible by 7. So you got the list of numbers which are divisible by 7. The numbers which are divisible by 7, they are 105, 112, 119. So the last number is 994. These are the only 3-digit numbers which are divisible by 7, the number 7. Okay, so this is how you can find out the list of numbers now. This is in AP. So it is in AP now because it is in AP with the first term with A is equal to 105 and B is equal to, common difference you know that it is 7 because it's a multiple of 7. So then last term AN is equal to 999, so 994. So you got the first term A and the common difference D and the last term 994. By looking this list of numbers, you can find out these numbers. So what is that? How many numbers are there? Such numbers are there. For that you have to find out the value of n here. So n is question mark. So this we want to find out. Okay. So use the nth term formula to find out this one. So let us use the formula A is equal to A plus n minus 1 into D. Okay. Nth term means the last term, that is 994. First term A, it is 105. So you can write here 105 plus n minus 1 into common difference is D. that is common difference D is 7. So simplify this one, you transfer 105 to the left side. So 994 minus 105 is equal to, so 7n minus 7. So now if you subtract this one, 14 minus 5, it is 9, 8. So 9 minus 1, 8. So 889 is equal to 7n minus 7. Transfer 7 to the left side. 889 plus 7 is equal to 7n. So now 7n is equal to, so 16, 9, 896. n is equal to 896 divided by 7. So divide this one. So now if you divide this by 7, 7 ones are, so 7 ones are 7, 1 remains 19, 7 twos are 14, 5, 56, 8s are. So therefore you can write n is equal to 128. So that means there are, you can write the conclusion, there are 128 numbers, 128 3-digit numbers, 3-digit numbers which are divisible by 7. So this is the conclusion. So you will get 128 numbers which are exactly divisible by the number 7. So that is the conclusion. So here, for what value of n, the nth terms of two APs are equal, they have given. The two APs are given. So let us find out the nth terms of both the APs. For first AP, what is the first AP? Let us write again, once again. 63, 65, then, so it continues like this, 65, 67. So like this it continues. So let us do it separately. A value, here A value is 63, common difference, D value. D value is 65 minus 63. What is the value of 65 minus 63? Common difference is 2. So let us find the nth value, nth term. An is equal to A plus n minus 1 into D. So An, nth term, 63 plus n minus 1 into 2. Simplify this one. 63, 2 into n, 2n minus 2. So 63 minus 2, it is 61 plus 2n. This is the nth term of the first AP. This is the nth term of the first AP. Let us take the second AP, that is 3, 10, 17 again. The second AP. Second AP, 3, 10, and then what is the next number is 17, etc. This is the second AP. First term A here 3, common difference 10 minus 3, it is 7. So let us use the formula, nth term formula, to find out the nth term. An is equal to A plus n minus 1 into D. So use the value here, 3 plus n minus 1. We do not know the value of n minus 1 into D, it is 7. So now 3 plus 7n minus 7. So what is the answer? You are getting 7n. So minus plus 3 minus 7. It is, what is the value? Minus 4. So you got the value of nth term here in the second AP, 7n minus 4. In the first case you got 61 plus 2n. And in the condition, what is the condition that they are given? So nth terms of the two APs are equal. The nth terms of two APs are equal, it is given. So let us equate these two terms now. Nth term here 61 plus 2n. So 61 plus 2n. First term 61 plus 2n. And it is equal to nth term of the second AP, 7n minus 4. So now you can interchange, transfer the variables to one side and the numericals to the other side. 61 minus 4 transfer to the left side, it becomes plus 4. And 7n you keep here only, transfer 2n to the right side, it becomes minus 2n. So 65 is equal to 5n. So n is equal to 65 divided by 5. So n is equal to 5 ones are 5 threes are. So 13th term. 13th terms of both APs are equal. Is it clear? So look at this. So what is the question given here? So here we have two APs and they are clearly given nth terms of both the APs are equal. We have to find out the nth term here. So let us take the first AP. First AP given is 63, 65, 67. From this you collect these details. So these details can be collected. A is equal to 63 and D is equal to 2. Apply to the formula. So once you apply to the formula, you will get this equation AN is equal to 61 plus 2n. This is the nth term of the first AP. Come to the second AP. Second AP we have selected, that is 3, 10, 17. This is the second AP. From this you will get the values A is equal to 3 and D is equal to 7. And substitute in the formula, you will get the second equation, that is nth term of the second AP. It is 7n minus 4. And it is clearly given that both the nth terms are equal. So equate them as per the data given in the question. So nth term of first AP, that is 61 plus 2n. And it is equal to nth term of the second AP. So if you equate, you will get the value of n as 13. That means 13th terms of both the APs are equal. So the given question, determine the AP. You have to find out the arithmetic progression whose third term is given. It is 16. And the seventh term exceeds the fifth term by 12. So let us write the data first. A3, it is 16. This is the first information. Okay. And the second one, seventh term exceeds the fifth term by 12. That means seventh term is more than the fifth term by 12. So A7 minus A5, it is equal to 12. So this is the second information you are getting. Using this, you have to find out the arithmetic progression. To find out the arithmetic progression, we need to find out the A first term and then common difference. Using these two information, you need to find out the first term A and D. Then only you can find out the arithmetic progression. So let us see now. A3, first one, third term is 16. So A3 is equal to 16. We have nth term formula AN is equal to A plus n minus 1 into D. So let us write here A3 is equal to A plus 3 minus 1 into D. So A3 here it is 16. Substitute that 16 in place of A3 is equal to A plus 2D. 3 minus 1 means 2D. 2 into D. Okay. So that you got one equation. Using the first information, you call this as 1. Now take the second information given. That is 7th term exceeds the 5th term by 12. 7th term exceeds the 5th term by 12 means if you take the difference 7th term minus 5th term, it gives you 12. So let us use that one. 7th term A7 minus A5, it is 12. Directly you can substitute to the formula. Once you have already written, you can substitute here. A7, so that is A plus 7 minus 1 into D. So this is the value of A7 minus A5, A plus 5 minus 1 into D. So it is equal to 12. You can simplify this one, A plus 6D. So then minus A plus 4D, it is equal to 12. Okay. Now simplify this equation. A plus 6D you can write as it is. Now you multiply minus here inside the bracket. Minus into plus minus, minus A, then minus 4D. So you have multiplied here minus inside the bracket. Minus into plus minus, again minus into plus minus, minus A and minus 4D we will get. So that is equal to 12. So if you simplify this one, look at this positive A and this negative A gets cancels. So you are getting 6D minus 4D, it is 2D. It is equal to 12, D is equal to 6. So it is easy. So you got the value of D is equal to 6 and substitute in the equation 1. So we have A plus 2D. A plus 2D is equal to, so what is the value you got? 16. So substitute this D value here. 2 into 6 is equal to 16. So A plus 12 is equal to 16. A is equal to 16 minus 12. So A is equal to 4. So as I told, we need to find out the value of A and D, and you got the value of A and D here. Once you get the A and D, you can find out the first term, second term. So first term, A1 is equal to A itself, that is 4. A2, second term, it is A1 plus D. First term plus D. First term 4 and D is 6. That is 4 plus 6. It is 10. So third term A2 plus D. Second term plus D. So now you are getting second term as 10 and add the common difference. It is 16. So similarly you can find out the fourth term by adding common difference to the third term. So that is 16 plus 6. So like this it continues. So that given, therefore the AP is 4, 10, 16, 22, like that it continues. That's it. Find the 20th term. 20th term from the last term of the series, from this direction. You need to find out the 20th from the end, not from the beginning. So here, so let us reverse. Let us reverse the AP. Reverse the AP to find the 20th term from the last term, that is 253. Okay, so once you reverse the AP, so 253, and what is the common difference here? 3, 8 minus 3, it is 5. So it is 8 minus 3 is 5. So now what you have to do? So it actually this continues like this, and then you look at this 13, 8 and 3. So like that it comes. So you can find out the first term here, A is equal to 253. Common difference can be calculated by subtracting any consecutive terms here. That is AK plus 1 minus AK. Okay, so like that you can do this one. So B is equal to, you can do 3 minus 8 also, subtracting this 8 from 3. So you will get, it is minus 5. Okay, so A value you got, and then you got the D value. You can find out any term here. We want the 20th term. So let us use the formula AN is equal to A plus N minus 1 into D. So we want 20th term, let us write 820 here. So A value, it is 253. First term now it becomes 253 plus 20 minus 1 into D value, it is minus 5. So 253 plus 19 into minus 5. 19 into minus 5. So 253. So what is the product of 19 into 5? Huh? 95 minus 95. So now what is the difference now? What is the difference that you are going? 820. 253 minus 95.
150.
Subtract this one.
150.
So 13 minus 5, 8. So 14 minus 9, it is 5. It is 158. So that 158